Hello everyone, I am Animesh and welcome to my YouTube channel. So by now, if you haven't subscribed to my channel yet, please do subscribe to my channel. So let's begin. So today we are going to see a very important test in statistics, which is Dickey Fuller Test. We will be covering this topic in various subtopics. First, we will try to understand what is a stationary data, when to use Dickey Fuller Test, and what are its hypotheses. We will try to understand the stationarity with some example, and then we will deep dive into hands-on implementation of this test using Python. To start with, we need to first understand what is a stationary time series data. So in a very simple language, a signal or a time series data is said to be stationary if its parameters such as mean, variance, amplitude, frequency do not change with time. In other words, we can also say that any time series data that does not exhibit seasonality or trend is a stationary time series data. So in a more concise way, we can say that any time series data in which certain parameters do not change with time is a stationary time series data, or the seasonality and the trend are not present in that data. Okay, moving on to the next slide, we will now understand what is a Dickey Fuller test and when to use this test. So a Dickey Fuller test is used to see if a time series data is stationary or not. So this is a very conclusive test with certain confidence, and there are certain p-values with which we can set the threshold and say beyond that the data is stationary or it is not stationary. Now when to use this test? We can use this test on the time series data where one column is a quantifiable column or it is a quantitative data, but its index is a timestamp. That is, it is representing some day, month, hour, etc., which is an index. It is used as a part of exploratory data analysis, and we want to know the time series data has got stationarity or not, because this is very important to know to get a model, a machine learning model, to give very accurate predictions. Now let us understand how we can draw the hypothesis. So in Dickey Fuller test, the null hypothesis says the data is non-stationary, and the alternative hypothesis says the data is stationary. In very simple words, there are various explained definitions available across various sources, but to keep it concise and easy to remember, this is sufficient for us. And when we want to apply it, then we can remember this very easily. That is why I have kept it very short. Now, let us understand the use of p-values here. Now, if we have a threshold of 0.05 and the p-value that is coming from this test is less than 0.05, we will reject the null hypothesis. That is, the data is stationary. Okay, and if p-value is greater than 0.05, we fail to reject the null hypothesis. That is, the data is non-stationary. Now let us understand this better with some examples. So I have got some very interesting plots for you which will bring immense clarity of stationarity in the time series data. So here are some plots. You see, there are various plots of different use cases where you will see in some plots there is some trend already being seen. For example, A, you see E, very easily you can see in I also, and also in some of the plots you can see there is some seasonality. You see a seasonality in I very well, very clearly, although its amplitude is increasing. And also you may see a seasonality in D, and carefully you will see in other plots also such similar features and characteristics. But in some plots, like for example B, you will not see anything, either trend nor seasonality, nor you will see any changes in amplitude, frequency. Everything is looks like it's just data. Here we can draw an insight that this looks like a stationary data. So let us just pause this video and just evaluate yourself, and then I will give you the answers with a very basic logic so that you can improve your thought process and intuition behind it. Okay, it's time for answers. So B and G are the stationary data, whereas we already saw some trends in some of the data set like A, E, I. There the stationarity doesn't exist, so these would be non-stationary data, and similarly all other except B and G are non-stationary data because there is either the trend or some kind of seasonality present in that data. You see, these are all non-stationary data, and the reason are trend that we already saw and seasonality. Okay, moving on to the hands-on using Python. Let us now import some of the important libraries that we will be needing, and I'll just execute it, and then let us collect the time series data, and then we can also see the top 5 rows of our data set. So here, important thing to note is that we have imported a stats model library, and we are importing add Fuller. This is a Dickey Fuller Test with A, that is augmented Dickey Fuller Test. This is an extension of Dickey Fuller Test, but let's not go into too much of detail because that will increase the scope of this video. If you want, then I can make a separate video in explaining this, but for now an application this much is enough. So if you see in that first 5 rows of our data set contains the date as the index, and there is the information, that is the production for this particular date. Now let us plot a time series plot, line plot, with which we can get some idea about our data. So here we can clearly see that there is some trend and there is some seasonality as well. So by looking at this, we can say that the data looks non-stationary, and this is just an insight because we have not tested it with some tests. Here we are going to confirm this using a Dickey Fuller test. So we have already imported the add Fuller library, which we are going to use. So what we are going to use is the add Fuller function, and inside we are going to pass this argument, which is nothing but the production column information, and we will just simply execute it, which will give us all the information with this test, that is the statistics, the p-values. This will give us the lags used and the number of observations used, but for our importance is only the p-value, because based upon the p-values here we can easily identify whether it is a stationary data or not. So you remember that we also already plotted the null hypothesis and the alternative hypothesis. So based on that, we can create a condition that if p-value is less than 0.05, it should reject the null hypothesis, otherwise it should fail to reject the null hypothesis. And let's execute it, and we get fail to reject null hypothesis. The time series data is a non-stationary data, which now confirms our observation because we get 18, which is much greater than 0.05. Okay, so this was it in this video. If you guys like this video, then please do subscribe to my channel. I'll keep on bringing some very authentic and very informative content for you guys. See you in the next video. Till then, take care.